Linking versus embedding. Which one I can use? I'm using NoSQL database. Do I need to design the data? Do I need to data model in MongoDB just like I have been doing in RDBMS? If I am going to use e-commerce application, would it make sense if I design my schema beforehand before working on the application? I'm going to work on time series database. I'm going to work on IoT database. There are so many situations where a data modeler or a developer has to make a decision whether they have to design the data model in real time or as soon as the requirement comes or before starting to develop the application. So in this video we are going to find answers to all these questions. So I'm going to talk about different data model practices. We are going to talk about one-to-one relationships, one-to-many relationships, many-to-many relationships, how to handle those in MongoDB. What will happen if a sudden requirement comes to change the schema? All those questions I am trying to answer in this video on MongoDB data modeling. In the subsequent video, I am going to post design patterns specific to MongoDB. There will be around 10 design patterns which will help to decide what kind of data model should be designed when working on different use cases. Agenda is what is data modeling, key concepts, design patterns, demo with scenario, and moreover there will be a quiz also which will be for you, and I will be looking forward for your answers in the comment section. So what is data modeling? Data modeling is designing of the data as per the requirement. If I am going to work on IoT use case, then how should I design my MongoDB schema so that it performs in an efficient manner and the best possible way? That is what is data modeling is. It is critical to ensure because it will lead to desired performance, flexibility of schema, change at later stage and any time, or scalability also. What does scalability mean here is that we have one node, right? It should not happen that in case my data reaches beyond the storage capacity of one node, or we want to leverage MongoDB sharding, replication, etc., right? Then whether my data model will be able to scale or not, or whether it provides the flexibility to change at later stage or any time also. So all those things come under data modeling. And one more thing which I would like to caution you here is that please don't get into a practice where you want to design your data model or schema before starting to develop the application, because that is very crucial. That is what that is the biggest advantage of NoSQL databases, right? That we can change the schema as per our requirement going forward during the development life cycle of the project or application, right? We will be having flexibility to change the schema at any point in time. I'm not against the practice of thinking the schema before starting the application development work. It should not be so stringent that without designing the schema we cannot proceed further. While designing the data model for MongoDB, or for that matter most of the NoSQL databases, you should focus on access patterns. What does access pattern mean? That how your application is going to access the data from the database. This is a critical consideration while designing the schema for MongoDB. Flexible schema, capability to change schema at any point in time. Document structure, that how your document structure should look like. Whether you want to have embedding, that is that you have a main document If you are not aware of MongoDB, then please look my other videos where I have explained the details, what is JSON, what is MongoDB, and introduction to MongoDB. For now, I am assuming that you are familiar with JSON structure as well as you have a basic understanding of MongoDB, and you have been developing in MongoDB or related technologies for quite some time. So here embedding data means that we have a main document and we want to include the sub document, right? Again, nested JSON, you can say that this represent a nested JSON. We want to store this information within this document, within the main document. That is called as embedding. Okay, so now here we have main document, ID, username, and we want to store contact access level within the same document main record. Another option could be we want to keep it into separate collection in MongoDB, right? And we want to refer that ID within this or this ID in that. That also we will see in the subsequent slides. References, like here I was mentioning that user, this is the another way. We have a user document where we only have ID, username, right? And then contact document, and in this contact document we have placed reference to this user ID. So it is pointing to this user ID, and there we are storing phone and email, right? And here we are storing the ID as a unique record ID to make this record as a unique. And same way access document. So you can see that these are the three collections, but here we have only one collection. So these three are the biggest considerations while designing the schema in MongoDB. So please make sure that you understand all these things. Biggest impact is of access pattern. If you know your access patterns, right, then you will be in a position to decide whether it is embedding or referencing. Then that will lead to efficient performance of your MongoDB database. Data use and performance will also be an important factor, because you should know how your data is going to be used and what performance you want from your database. It might be the case that you want a millisecond latency, or you want the response in 2 seconds, or it is fine if MongoDB returns the response in 5 seconds also, right? So based upon these considerations, you can efficiently design your MongoDB schema, correct? So days have gone when schema validation was not possible in NoSQL databases. So MongoDB has come a long way when it comes to validation of schema. We can enforce schema validation, like if we want to have let us say string in one field, right, whether we want that to be mandatory, that field should have or must have an entry in that, we can make that field as required also. We can enforce schema in MongoDB by using schema validation while creating the collection, as well as after the collection has been created. That time also we can impose the data schema validation in that particular collection. It ensures data accuracy during updates and insertions, right? And then second advantage is rules can be defined per collection basis. So it will not be applicable across the whole database. It will be applicable for different collections. Use db.create collection with the validator option. I will walk you through various schema validation options mentioned here, and it can be applied to an existing collection also. So now let us start. So I'm going to create a collection called students, right, where this is validator, this is the syntax, again JSON schema, this is also a part of syntax. BSON type, again this is the syntax part. Required, now what all fields are required: name, year, major, address. properties. So I can now define this name to be a part of string description, right, for future understanding. Here I want it to be an int, minimum value, maximum value, you can see that, right? So I am giving so many values here, right? And then uh, major, I am talking about enum part, so it will accept either four of these values or null, right? Then GPA double. So this way I can impose schema validation here. Let us start with the first key concept here. Access pattern, as you can recall from the previous video in this series where I have talked about the importance of access pattern. So let us see how the data will be accessed by the clients, right? So it could be mobile client, it could be web based client, or it could be reporting requirements also, right? So then in that case you should consider the access pattern, identify queries of your database. Examples could be user wants to view listing of all the employees by department. So please note that from the employees collection we can find out easily that what we can fetch all the employees from the employees collection, but here by department is the key here, right? You should be able to find out all the employees by department with the minimum possible time, with minimum latency, right? So that is one access pattern. Second is a user wants to view the average salary at different levels of employees, right? So it could be that level of employees as well as average salary. If we have to design, if we have to design the database of employees, then we will have to consider embedding versus referencing, right? Whether embedding will help, whether department ID should be there in employee ID, right? Or employee ID should be there in department collection, whether we should compute average salary for all the employees, or whether we should have level also within the employee collection, whether we have thousands of levels, right? All those parts, things we will have to consider. Then only we should start designing the database or schema, right? So that is one important aspect in data modeling of MongoDB. What are embedded data model? Embedded related data in a single structure or document. We want to store our data in a single document, in JSON single document, also called denormalized. We are not creating or maintaining multiple collections to maintain relationships amongst different entities, right? So it is one collection which is having data of all the relations or most of the relations in that particular collection in the form of embedded documents. Normalized data models, the second form, it uses references for the relations among tables. Now, with this approach, if we follow normalized data models in almost all the NoSQL databases, there are no referential constraints or integrity constraints which have been there, which can be applied across collections or across tables. So in this case, when we are talking about references, it is more or less like normalized data model, which is one table is referring the data in another table, which is primary key, foreign key kind of relationships, right? So in that case, if we go with this approach, application must take care of joins and integrity of the data. We will have to take care of all those things at the application level, right? Now question is which one to use when, right? Let me talk about that also. Embedded data models, when to use, when there is relationship one to one or one to many relationships are there. On the right hand side of the screen you can see that this is embedded model, right? We have user and we are supposing that one user will have one phone and one email, right? And access also we can have controlled. User will have one level of, or a user will have the access defined at a single level only. User will not have multiple records of access. We can manage those in a single document. So that way we can use embedded data model. For one-to-one, embed the document in the document meant for query. For example, a student with one address can be embedded into the main collection. It should not be the other way. What will happen in case of one-to-many? Again, embed the child document in the parent document. For example, an e-commerce customer with multiple addresses. Addresses will be a part of main collection, which is a customer collection. It should not be that we have address collection and there we are embedding customer as a part of, because customer is going to be queried most of the time. We will not query on addresses, we will query on the customer side. Embedding benefits: it will lead to better performances for read operations, ability to request and retrieve related data in a single database operation. We will not need to have multiple operations to retrieve data from multiple collections. Make it possible to update related data in a single atomic write operation as well. Referencing: when to use it? When embedding leads in duplication of data. So there could be the possibility that when you are going to embed the data, so it will lead to duplication of data. To represent more complex many-to-many relationships, use $lookup to join such collections. $lookup is a MongoDB construct which can be used to perform joins across collections. This will help to fetch data from the collections where the data is designed in the normalized form. So if you see on the right hand side, this is an example where we have a user document and we have a contact document and access document. So if you see, user ID is referred inside contact document and access document also. So if we want to fetch data, we can use $lookup. So in this part of this MongoDB data modeling series, I'm going to talk about operational factors and data models which impact the performance and other aspects of the data modeling. Atomicity leads to the fact that how whatever operations we are doing on our MongoDB collections or documents, so each operation is being done at the document level. So if we are doing insert operation or update operation, it is happening at the document level. Sharding, again, selecting an appropriate shard key is also a part of data modeling only. Indexes, again, before implementing indexing, please note down some of the behavior of indexes so that while selecting an index, you are comfortable or you are well aware of the fact that how indexes are meant to behave. Each index requires at least 8 KB of data space, so it is not a big constraint, I guess. Adding an index has some negative performance impact for write operations. Why? Because for each write operation, index also has to be updated. The corresponding entry has to be made in the index, as well as when we are going to update that time also index also might have to be updated in case that index involves the value which is being updated. Collections with high read to write ratio often benefit from additional indexes, right? Where read is heavy, then right there we benefit from additional indexes. Large number of collections also is an operational factor where it could be possible that we are storing all the data in one collection, but eventually it may help to have multiple collections to store the same data. Maybe one example could be that we can have logs collection, different logs collection for different environments. For example, it could be dev collection for dev logs, same way stage collection for stage, and same way pre-production, production, and so on. Consider embedding of small documents if collection contains large sum of small documents. So we can think of some logic wherein we can have a big document which contains linking between those small documents and can be stored in a single document. Storage optimization for small documents. Most of the time developers use it as the object ID which is auto generated, or in case of users we can store user email or user phone number so that these are unique, or in case of products we can have some unique attribute which uniquely identify the products, right? For example, it could be SKU or some other field which even differentiates the different products. Shorter field names, right? Then embed documents. Shorter field names could be that in case we want to have a very long field name that can be avoided, embedding of documents is preferred. Data lifecycle management, maybe we want to have time to live feature enabled for the data with short life, right? Maybe for logs, we do not want to store the data for complete 6 months. We want to move it to archive collection, right? So capped collection may also be used for this purpose. I hope this will give you some insight onto operational factors, right? Whether it comes to selecting the shard key or some other aspects where the document size is small enough. In this part of the data modeling series, we are going to discuss one-to-one relationships, how to model those, though we have already seen in previous sections, but this is the complete detail with one example here. Embed the document into the main document. As you are already aware, embedding can reduce the number of read operations from the different collections. We will be able to read one collection in case all the data is there embedded in the single collection, versus if the data is there in two collections, either we will have to use dollar lookup or we will have to query multiple times. So this is the example customer document, address document. There are two documents. After embedding, this is assumed that customer is having one address. Combined ID, name and address is merged into that. It is embedded. Embedding challenges. What could be the embedding challenges? Have you given a thought of to it that what could be the embedding challenges? The document size can become large, right? It could be so large that it will lead to performance issues. For example, in case let us say customer is having 3-4 addresses, right? And then in some other case product is having multiple reviews or movie is having a multiple reviews, right? So that way the document size can grow very huge. The query may get unwanted data. So some of the developers may fetch all the data. In that case, the data size which is being returned from the database, it will go too high. Potential solution. Now we have discussed challenges. Wherever there is a challenge, there could be a solution also, possible solution. Move the least access required data to a new collection. So that I am going to explain in next slide, that what does it mean. So this is the large document here to model one-to-one relationships using embedded document style. I'm going to introduce subset pattern. So if you see here, this is the example which is showing that data in a single document may grow very large. Now what to do? If you notice here, reviews are there. Reviews, it is only showing one review from, but it is an array. There could be 10,000s of reviews or hundreds of reviews, right? But we do not want to fetch all the reviews in a single go, right? What should we do? In that case, subset pattern comes to our rescue. Move least frequently data into another collection. For example, we can have top 5 reviews which have been submitted. Maybe we can sort it by date in the collection, or we can keep only last 5 reviews and move rest of the reviews into the separate collection for reviews. And in future, whatever review is coming, we will store it in the collection and move one review from that collection into the other collection. So this logic you will have to implement at the application level, because it cannot be automatic at the database level. It leads to the performance improvement, so that in case we want all the reviews, right, then we can anytime we can fetch data from other collection which is having all the data. There also we can fetch in the pagination view. For previous example, create two collections, like one for reviews to return with the product data. Second is one for all of the leftover reviews, right? That I just explained. How to model one-to-many relationships when it comes to embedding? It follows the same principle as in one-to-one relationships of embedding. Prefer embedding, right? Here also we prefer embedding. Avoid large documents, which is again we want to use subset pattern here also to avoid large documents. Use subset pattern. Additionally, identify patterns to access this data, right? So we can use other patterns also, other design patterns also to access this data, which can be designed based upon different use cases. Now again, subset pattern challenge. It requires respective application changes. Example, handle duplicate records logic at application level. So this is the biggest constraint with subset pattern, where we should use one to many relationships using referencing, again where embedding may not fit all the scenarios, right? So it might happen that we have books collection as well as publisher also. So when we are going to store publisher information inside a book information, that is not possible, that may not be possible, right? So in this scenario, publisher information is getting repeated across the books, right? One publisher may have published so many books, so that way the embedding may not be feasible in this kind of scenario, right? We cannot embed publisher information in the book, because it will be difficult to imagine updating this information when it comes to updating publisher information, because that will be so problematic or so performance consuming that it will be write intensive job. And we cannot think of storing book information inside publisher, because that publisher might have published thousands of books. Embedding will not be possible in that case also, and moreover that will lead to performance issues in both these scenarios. If we embed publisher information into books information or books information into publisher information, both of these are not feasible in this case. In this case, use referencing.
refer ID either as array or some other possible way, which I'm going to show you. Approach 1. Store books information in the publisher collection. We can have publisher collection, and inside that we can store books ID in that this publisher has published these many books. Approach 2. Store publisher ID in the books collection. Right, so this approach, again, it will depend. Now a question for you: which approach do you think will work and why?
You will have to work on those use cases, think on those, share with me on my different social platform channels. It could be GitHub, Facebook, my website, LinkedIn as well. Assumption: don't limit yourself to any existing project or your thoughts. Think of application access pattern and feel free to think of any access pattern which you can think of and design the database or schema accordingly. You have to consider these scenarios, one of these or multiple scenarios, to do items. All of these are independent of each other. To do items, right? Create an item, list all the items, change an item, update an item, right? All those things along with time, along with the user who has created that, right? With reminder, when the reminder was sent, cab booking like Uber or Ola, right? Or some you want to create your own schema like Uber or Ola, right? Cab booking system, leave management system, project management system, food delivery application. In case you are not aware of any of these or some of these requirements, I can help you with that also. I can post these requirements on my GitHub page as well, so that you can refer those and design your schema. So with this, I think we have reached at the end of data modeling video series. So please feel free to connect with me on different social channels. Please don't forget to share your feedback on this data modeling series with me. That will encourage me to work more in this direction and improve on. So thank you so much in the end for watching my video series, and I hope you have liked this video series and you have learned something. In case you have learned something, please share with others as well as let me know that it has helped you, so that I can create more better videos and share my knowledge with you. In the end, thank you and love you.